important. So with the engine at top dead center, and I'm going to show you here on the set that is pre-machined. Here's the crank gear, and this is the cam gear. And it's a little difficult to see, but on these pre-machined gears that we supply, there actually is, I don't even know if I can see this on here, there is a little mark machined into the surface of the gear, which is at 180 degrees. It was just placed there so you could see the alignment with the crank gear. So if you look this direction, this is the front of the engine, and this is the rear end of the engine with the crank right here. So if we look in here again, you can see the cam is inboard near the base. The cam is outboard towards the flywheel. Here's the profile of the cam again, for those who might have older engines that may have machined this cam themselves. It can be a little tricky when you look at the original plans, because at first it may look like this was supposed to be machined outboard, and if you did that, the cam profile would actually be backwards. So here we have that pock mark, or that little machined mark, and it's in there pretty good. It's just kind of hard to see on the video camera. And if you line it perfectly with the crank gear on the crank with the engine set to top dead center, if you install them like that, then the engine is timed correctly and should run if all other adjustments are correct. But this one can be a little tricky, because if you don't know if you don't have your timing gears set right, you can pull your hair out over that. So just set them right the first time and then worry about the other items of getting it started. So you can see here a little bit, right at top dead center, you can kind of see where the curve of the cam is, and the little bump up here, which is this right here. So that's what it's riding on right there at top dead center. Now that the cam gear and crank gear are installed, and installed in the proper orientation, make sure the set screw on the crank gear is good and solid against the crank so it won't move. And you need a degree wheel or something to tell you how many degrees you've turned on this side of the flywheel or on the crank somewhere, so you can tell how far you've rotated it. And you're going to rotate it approximately 70 degrees. When it's at 70 degrees, and you're going to rotate the flywheels, if you're facing this side, it's a clockwise direction. You're going to rotate it 70 degrees. At 70 degrees, or very close to that, the exhaust valve should start opening. So if you set it at 70 degrees and use your adjusting screw on the rocker arm to just start opening the exhaust valve at that point, you should be good. Where that is on the cam, is this large high lobe right here. As it gets to here, as the push rod gets to here on the cam, that's a little hard to see, it's going to start pushing the push rod up, and that's where you're going to have to adjust the screw on the rocker arm to just touch the exhaust valve, and it's going to start opening it. Tighten the lock nut down when you get that adjusted, and now you've got the timing gear set right. You have the exhaust valve opening at the right point in time, so that's a good part of the timing down that you don't have to worry about anymore. Just as a side note, this engine runs in this direction, so make sure when you try to start it, if you're facing this side, it'll be a right hand or clockwise direction. The next part we're going to talk about is ignition timing and the ignition system in general. Here you can see the points right here, which open and close. This wire here is actually going to the negative side to make contact with the negative side. Don't let the red wire confuse you. It's just what I had. typically you use black for ground. But as the engine approaches top dead center, just before top dead center, the points should open. If they're not opening right just before top dead center, about just a couple degrees before top dead center or about top dead center, you're going to need to adjust this screw right here. Oh, hard to see. Spring loaded, so you can adjust it back pretty far. And this bracket here that holds this insulator can be adjusted if it's out of position. This here, if you follow the drawings and the dimensions on the drawings, it should be fine. It should work just fine. With these adjustments here, you should have plenty to get that so it opens at top dead center. Another thing to note about this is that you're basically using a circuit through the engine. So if you measure continuity with a voltmeter from here down through this wire when that's connected, you should have continuity through that. If you don't, you need to trace that and figure out why you are not breaking and making contact there. Another way to test this, once you have that set so it opens just before top dead center, is to pull the spark plug, ground the spark plug to something on the engine. Keep your fingers away from that, kind of on the wire or somewhere like that, but keep this grounded. Look at the end of the spark plug, and when you spin the engine, you should see a spark. Okay, I have a wire wired from the end of the spark plug just sitting over the push rod, which is grounded through the engine. And I'm going to turn the lights off here for a second. Make sure you turn the power on. You can see the spark there. So that tells me I have a good ground through the base of the engine to the ignition circuit, and I'm getting a good spark off the spark plug. And you see a little spark off the points. That should be minimal and should be reduced by the condenser. We now have the timing gears aligned properly, the ignition timing timed properly, spark to the spark plug. We determined that we have spark at the spark plug, and now we have to adjust the fuel system. The fuel system on a hit and miss engine, especially like this, is can be a little tricky. You can see on our model here that we have the fuel tank sitting down to the side. You can either mount it higher, or you can do what we did here. This little thing here is just a check valve. There's a little ball that's sitting in there that as the fuel is sucked up here, it sucks up enough there and doesn't let it run back into the tank, so it's at the level or almost at the level of the carburetor. This carburetor body here, there's an open space up here where some raw fuel sits, and it's basically drawing in the vapor and running off of that vapor. These hit and miss engines like this, especially what they call the mixer on the older style, the real hit and miss engines, there's a lot of raw fuel sitting in the bottom and it just runs off the vapor. It's not so much like a Venturi type carburetor of today. The compression on this is fairly low. You're drawing the intake valve open from the vacuum, so you want some vapor sitting down here. It runs fairly rich, and if it runs a little too rich, you'll hear it go blub 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 a little bit, and then you can lean it out a little bit. But here we have a little choke lever to control the airflow to fuel flow ratio. It's important that this needle, when you machine this body here, that everything lines up and that this needle seats very well with the hull, because if it doesn't seat properly, you won't be able to get the proper air to fuel ratio mix. And if you put the fuel tank too far away, you're also going to have issues. Our Galloway engines, we actually mount the fuel tank up here, and it's gravity feed down here, but it has a mixer carburetor and some fuel sits down in there, and it draws up the fumes along with the air and runs off of that.